Hey everyone, John Capobianco. I'm finally back with another video. I know it's been a while, but I've been busy working on a new MCP I found that had some friction that I'll go over. Actually, I'll explain every step of the way where I had some problems and what it took for me to overcome those problems. Now, I want to preface this by saying I have it working. It doesn't look the best yet, but I'm not worried about that. And I'm not a JavaScript browser-side coding wizard or expert by any means. Far less skilled at that than Python, which I'm barely skilled at. So, I have it working. And we're going to explore this. So let me start sharing my screen. So before I get into drawing it, have you heard of Drawio? So this is apps.diagrams.net. And we can save it where we want, and we have this visualization where we can add things like rectangles and circles and whatever. It's got all kinds of stuff here, text, style, arrange. It really is like a mini Visio, but I hate to compare it to Visio, but it's kind of neat. You can have arrows and you can animate all this stuff and everything's easily editable. It's pretty neat. So, I found an MCP server for Drawio, vibe diagramming. Imagine doing vibe diagramming from your network, or as this title implies, self-diagramming networks. Now, as you see, there is a browser extension set up, still pending review. They're still working on the browser side code, but I just went ahead as a go-getter and tried to figure this out on my own. And a couple of things. So, this is a great place to start. I had to modify this significantly to make it work. So here's the idea. I have my LangGraph and I have my tools, and these tools discover, this toolkit is made up of tools discovered from MCPs. So let's blow it up over here. I found a Drawio MCP. Now what's interesting about this one is that it listens on port 3000 in order to communicate with a browser. Let's make it a diamond. Right? So I'm going to say browser. Now what's neat is over here, right, the existing MCPs that I've been working with, they typically work with things like REST APIs, Python scripts, databases. I've never seen one that actually interacts with a browser. Now this browser needs a script that handles the push from the MCP to the browser. Right, so if we think for a second here, forget the agent up here for now. I have a Streamlit front end here that the user talks to, right, some user. Right, to Streamlit to the LangGraph over port 2024. And this is a three-way handshake. We start a thread, we get a response from a thread, we then go ahead and start our prompt, right? So this is the prompt. Now what I can do is say, can you please get the CDP neighbors or the MAC address table or something? And I'm going to draw here the pyATS MCP with its own tools. Various tools. Right, so can you get that data? And then can you draw the network topology in Drawio, right out to the browser screen? So you're going to see here a couple of things. Let me bring up my containers. And let me crank up the zoom a little bit. I'm not going to show a lot of code today. I will show you some files and some approaches and how I figured this out. But what you're going to see is 1, a Drawio folder, and 2, a Drawio MCP folder, and 3, my MC pyATS client. All right. And the pyATS MCP server and a bunch of other servers. This is for me to actually build a container that runs Drawio locally in my browser, because it's open source and there's containerized versions of Drawio. I have this script that is my browser side listener for instructions coming from the MCP. All right? And the Docker file injects that into the base running index.html. The Drawio MCP is basically from the community, except I made a Docker file, and I also rewrote it a little bit to listen on TCP instead of STDIO, and I'll explain that in my friction in a little bit. And then my pyATS discovers this a little bit differently. Because I switched to TCP, I'm going to discover it through the remote procedure call over the port that I open. So if I go back to my diagram, oh, the diagram's gone, hang on. This MCP server here is listening on 2 ports. It's listening on 3000 between the browser and the MCP, and it's listening on, I don't know what it is, 11434 between the MCP tool discovery and tool calling and my agent. All right, so it's listening on 2 sets of ports. So this is my Streamlit and everything's up, and this is where we're going to drive things from. And you can see all of my different containers are up. Now let's pay close attention here. This is the Drawio, and it's up on 11434 and 3000. And I'm going to open up this browser, hang on, and visit the container. So you can see here, client ready. So I've effectively connected this browser to this MCP server. All right, so now I'm going to pass in. Let's just start with the demonstration. Can you please draw a red square 150 by 150 at 500x, 500y with, right, made by MCP as the text in Drawio. All right, so this is going to churn. We see the prompt come in, and then we see the pyATS container call the tool here and draw that square. It passes back to the draw, to here, and we post this body into the browser, and check this out. There's going to be that square at those dimensions made by MCP. Now what's really interesting is, I can do things with this square. It's not just a hard-coded square. I have full interactivity and can do what I want. I've actually made a Drawio object here. So let's look at the console logs. And here's what happens, right? We see the WebSocket open, we see it hooked into the editor UI, and the graph is now ready. And now I'm sending in this object through my RPC call, tools call, that draws that square with those parameters, right? Now, why is this dashed in green? That's me troubleshooting. I was drawing these squares all over the place, and I had a real struggle honing in on the right window. And quite literally, as soon as I saw this light up, I knew it was going to work. So let's go back to my Excalidraw, and I'm going to explain some points of friction that I found during this process. So my first point of friction was here in the MCP. Okay, the get clone is STDIO. And I tried both adding a one-shot mode and a persistent mode. And I could not get either of these things to work. I would discover the tools, I would call the tool, and it would time out. You know, I had a bunch of friction here. As soon as I switched it to HTTP, I was discovering and calling tools. The next huge bit of friction was down here in the browser, right? Again, because I am not proficient at browser-side JavaScript. So this was a lot of vibe coding back and forth, and ultimately I did get it working. I mentioned some of the friction I had and why I highlighted in green and stuff. No real other friction here. So let's show this full flow with pyATS. So we're going to refresh this and say, can you please gather the CDP neighbors from R1, SW, or R1, R2, SW1, SW2, and provide me a network topology in Drawio. Now I'm going to be a little more specific. Let's give it some parameters here, right? Can you use different rectangles to represent the various devices? And can you draw connections showing the interfaces to really help me understand what this network topology looks like? Let's try something like that. All right. Now, you're not going to believe it, and I'm going to refresh this so it's fresh. And we can watch the logs here side by side. So we're still in pyATS gathering state. So you can see pyATS is running show commands via STDIO, and we're on router 2 running the show CDP neighbors command. So it's already got router 1 somewhere. It's getting router 2 now. Right there's router 1 and router 1's payload. It's going to get router 2, switch 1, switch 2. The only, latency involved here is it's scraping those commands. And I hope all the devices are reachable. I haven't tested them. I should have in advance. Yeah. Okay. All right, good. So we see some calls coming in here, some various objects, and we have the final answer, I believe. Okay, there's even more objects, and we have this human answer. Here's the topology. R1 to switch 2, R1 to switch 1, R1 to R2, etc., and the different ports. And now in the visualization, we have the connectivity view. Now, I'm not saying that this is perfect, but it is accurate. It is correct. If we look at these lines and these descriptions, this is exactly how these devices are connected. And we can click on the connectors. We can change the size and move these around. Okay. So this is the topology view that it draws. I need to work on this. I'm not saying this is perfect, but isn't this cool? Isn't that one of the coolest things that you've ever seen? In a container that I'm building, in a container that I'm injecting this JavaScript into, listening over port 3000. I send in my request to my LangGraph agent that's bound to the tools and this MCP server over TCP, calls the tool generates the right schema for Drawio, pushes it into the browser as multiple calls as it builds multiple squares and then all the connecting edges as they're known. Like, I don't know what to say. I'm so happy and so proud that this works. I've put so much into this. So here's an open call to the community. If you are a server browser side JavaScript developer and can help me really make this special and fix that browser side code to maybe build it like a topology, build it like you would in Visio, make the things flash, add circles, add more and more objects, I could really use your help. I would really appreciate that. And I'm happy with the open source code to share all this. It's all on GitHub. Anyway, really neat. Let's do something else. Let's honestly, while we're here and while it all works, where did everything go? Here we go. So we're going to refresh the page and we're going to do a new prompt here. So I'm all listening. I'm all set. I'm all ready to go. Let's go ahead and say, let's just try something different. Can you please gather the MAC address table from switch 1 and draw a large rectangle for switch 1 with the label, and then smaller inner rectangles overlaid as interfaces, and edges or lines connecting to other colored rectangles representing the connected hosts with the correct MAC and interface connection from the pyATS data. Thank you. All right. So hopefully it's going to go ahead. I've already refreshed that page. So it's probably going to go ahead and run show MAC address table on switch 1. Right, you can see here, device name switch 1, show MAC address table. So it got, wow, look how fast that was. So what did it do here? So there's switch 1. And there's all the other objects. So it didn't quite do what I asked it to do. Okay, it's kind of neat though. There's the ports. So it did try to do this. It did try to draw separate interfaces for separate squares and then show you downstream the PC they're connected to. So a true wire map here. There's the host with the MAC address. Wow. Wow. Okay, so I've always been interested in this and convenience and automation and how it all can help us. Automated documentation, right? Business ready documents. I harped on that for about 2 years. It was an obsession of mine, was business ready documents. All the code for that is still out there. Mind maps, on and on and on. Now we're making Visios, Drawios from real network state. And again, I'll get some help. I'll clean it up. I'll do some more vibe coding. This is just early. I wanted to get this out there for the spirit of agility. So, MCPs have exploded since I've been on here last. A lot of people inspired by some of my work and some of my videos. Incredible. I can't even list all of the different projects that have made an impression on me. But there are so many out there. we are really going to soon have a super agent made up of network and infrastructure oriented MCP connections that we can really do remarkable things with. I've already seen some incredible stuff. So I'm trying to add to that landscape. Here is a Drawio, a working Drawio MCP with a browser side integration in a container. Really cool. All right, I'll talk to everyone soon. Thank you again.